We're going to continue a discussion of gases. We have a question here that asks about a gas that's at 1.421 ATM. That's a new unit for us. That's atmospheres. Yes, you had to learn this in the lab. 1 ATM. That's one way to show pressure. Here's another way to show pressure. Millimeters mercury. We can talk about that some other time. There's an Italian gentleman named Torricelli. That was his name, man. And he's the one that put his name on the unit there. Millimeters mercury says a little bit more, but Tor got his name on it. Okay. So what are we going to do with this? You know? We have to find a relationship between pressure and volume when temperature is constant. We had a very astute student say the final answer has to have a greater pressure. He is correct because he remembered what we said earlier, that if the pressure goes up, the temperature goes up. If the pressure goes down, the temperature goes down. We're not on that one, are we? We're not doing pressure and temperature. We're doing this one. Oh, man. I should have come up with an activity for one first, no? But he caught me. This says if the pressure goes up, the volume goes down. And conversely, if the volume goes down, the pressure goes up. It's this picture here. I've got one equation that governs this whole page. And it's the only one you need. It says under a certain set of conditions of pressure and volume and temperature, the ratio of pressure times volume over temperature will always be the same, even if you change the other conditions. There you go. And this, we're going to use all day. If T is constant, then they're going to be the same number for T on the left side and right side. You guys know a little math. Can you simplify the equation if T doesn't change? Please? T is constant. It's the same number. It's going to cancel out. Write everything you see on the page without any T in front. P1, V1. P2, V2. Comes straight from this one box. And we can hold any of the variables constant and narrow it down to just two variables. That's our next activity. Mathematically, if the temperature is constant, it will cancel out. I will put an example here and erase it. If they were both 200 Kelvin, multiply each side by 200 Kelvin. Cancels, cancels. What happened to your temperature? Gone. What are you left with? Exactly what we wrote here. We're going to use that on our activity right now. P1, V1 equals P2, V2. I need which of those variables by itself in this question? The one I need is pressure 1 or 2. Pressure 1 is the one you start with. Pressure 2 is the one after. Yes, I'm given pressure 1, and I need pressure 2. So tell me how I organize this equation to get P2 by itself. I can divide both sides by V2. Once again, I don't like doing that way because you don't know where you started. We started with that. That's the truth. And I'm dividing both sides by V2. Why? Because if I do that, then V2 disappears from here, leaving me with P2, which is what's asked for in the question. So P2 equals P1 is right there. V1 is right there. What does 311 mLs represent of my four variables? V2. Plug and play is what we say now. P2 is equal to P1 V1 over V2. P1, 1.421. V1, 426. And the units, if you did your math correctly, will take care of themselves over V2. And that's milliliters. Milliliters are gone. Surprise? Heck no. It's leaving us with ATM, which is a unit of pressure. And we're going to have 426 over 311. It went up. I'm thinking 1.7, almost 2. I don't know. Somebody's going to do it for me.
0.
Oh, it's got to go above 1.4. I'm just saying. It has to be above 1.4.
0.00.
I need an answer above 1.4. I'm not writing any answer that's not above 1.4. 1.95. 464. 464. 50161 ATM. We okay over there where you went wrong?
Yeah.
Okay. And then we got four, I think we're looking for 3 sig figs here. 3, 4, 3. I just want 3. 1.95 works for me. No surprise, pressure went up because you shrunk your container. Yeah, once I got to here, then I plugged into this equation right here. This was all that was left, right? And that's when I went over to there. P2 by itself equals P1 V1 over V2. P1 V1 over V2. And that's the end of that.